So the end of the last video was a bit of a disaster. I'm sitting there trying to figure out how can I explain this so that it makes sense. And so I'm sitting there pausing, and I think I'll just leave that there so you can laugh at me a little bit. So I guess the bottom line is when things start getting a little bit complicated, like the way they got in the last video, like I know what I wanted to teach you, but I wasn't sure that I was going to go about it the right way here. So let me just say this. As soon as things start going kind of crazy on you where you're not really understanding what the right values are, you're just you're picking values for t, and then you're not getting really nice whole numbers or integers for your x's and y's, then I would suggest, and I'm going to do this right now, I would suggest just going ahead and solving for t in the first equation, just like I taught you in the last video, and then substituting that value into the other equation and see if you can graph it in terms of x and y, and you go from there. So that's what we're going to do. We're going to solve for t when x is equal to t squared. How do you solve for t here? Well, you get t by itself by taking the square root of both sides, and so you get basically t is equal to the square root of x. You could say plus or minus the square root of x. That would be actually better. But it might be a little bit more confusing because when t is plus or minus the square root of x and you plug that into the next equation, you're going to run into a little bit of trouble. So let's just take the positive square root and see if that does it. And normally it does. If we need to go back, we will. And so we get y equals ln of the square root of x. And that's also ln of x to the 1/2, which is 1/2 times the ln of x. So y equals 1/2 ln of x, and that's our equation. That's our equation in rectangular form. And again, we can just pick x's and y's. Pick x's and y's, and we go from there. Well, we know what ln of x looks like. What does that 1/2 out in front of it do? Well, let's see if it changes anything as far as our key point. Well, if ln of 1 is 0, 1/2 times 0 is 0. So we get our key point at 1, 0. And also, if x is 1/10, we know that as I was saying in the last video at the end of that, when x is 1/10, ln of 1/10 is a really, really small number. Okay? And if that means a really small number, half of a small number is even smaller. So basically, for all intents and purposes, that 1/2 out in front of that ln of x is really not going to change the key parts of this graph. X has to be greater than or equal to, sorry, not greater than or equal to, just greater than 0. X has to be greater than 0. That's the domain of the ln. And half of all those values, half of 0 is 0. So really, the graph is going to look about the same as it otherwise would. And we don't want to put that little arrow like that. We want to do this. We want to show direction because remember, as the t values are getting bigger, the x is getting bigger, and so basically we get the shape of the ln curve with direction, and so the direction shows the motion of our moving object along the path of the curve 1/2 ln of x. And so that is my suggestion on how to best graph these functions. Figure out what direction it's going in, and then if you're running into trouble with the x's and the y's, then just solve for t, substitute it back in, and so you have y as a function of x. But don't forget the direction. I don't know how many times I have said that already. So we're going to do one last one before we get into the applications of parametric equations. And this is the one that involves cosines and sines. And these are kind of interesting because they force you to think back to what you learned back in, I guess it was Algebra 2 Trig. And you learn how to draw an ellipse, things like that. But I guess I probably gave it away here, but that's okay. X equals 2 times the cosine of t, y equals 3 times the sine of t, and t is going to range from 0 to pi. Okay, so here we have our setup. Those are the parametric equations that we're trying to graph, and again, two different ways to graph these equations. Pick your t, pick your x, pick your y. Well, I guess x and y depend on t, And again, though, let's let t go from 0 to pi. Now, 0 to pi, let's pick some values like pi over 6, so you can see a little bit there. Pi over 2, maybe pick a 2 pi over 3, and then pick a pi. All right. So when x is equal to 0, we know that 2 times the cosine of 0 is 2 times 1, which is 2. And then the y value depends on sine of 0. So sine of 0 is 0. So we have 2, 0. Okay, so we know we have a starting point of 2, 0. And let's do this. Let me mark it off like this better. Easier to see it like that. 1, 2, 3, 1, 2, 3. So 2, 0 is right there. We know we're starting there. All right, so that's a good starting point. The cosine of pi over 6 is radical 3 over 2. So we get 2 radical 3 over 2, which is just radical 3. Well, radical 3 is about 1.7, okay? And on the other side, we get 3 times the sine of pi over 6. So when t is pi over 6, we get sine of pi over 6 1/2, 3/2. Well, that's 1.5. Okay, so when x is equal to, I'm going to plot this, radical 3, which is 1.7, then we go up 1.5. So it's right around there. Oops, that's not it. It's right around there. Somewhere like that. Then when t is pi over 2, we get, let's see, t is pi over 2, cosine of pi over 2 is 0, sine of pi over 2 is 1, so we get 0, 3. Okay, so that brings us right up there. Okay, so far, the curve has gone like that. Okay, it's gone just like that. And then picking a couple other values, 2 pi over 3, cosine of 2 pi over 3 is negative 1/2, and negative 1/2 times 2 is negative 1. Okay, and then over here, 2 pi over 3, radical 3 over 2, so you get 3 radical 3 over 2. Well, I don't know what that is, so I don't care about that yet. Let's just figure out where it is when x is equal to, or when t is equal to pi. Cosine of pi is negative 1. Negative 1 times 2 is negative 2. Sine of pi is 0, so we go negative 2, 0. Okay? So logic would tell me that if I go up here like this along a nice curve, then I'm going to come down here like this along a similarly nice curve. And that's actually what that would look like, given direction, given the shape. But what is actually that shape? You might think, oh, that's parabola, just part of the parabola. Well, it's not, and I'm going to show you how to figure this out in the next slide. Okay, so let's 2 cosine t, 3 sine t. So we have x equals, okay, what's the problem here? X equals 2 cosine t, and y equals 4 times the sine, 3 times the sine of t. And again, t ranges from 0 to pi. Okay. And so how are we going to do this? Let's do this. Let's solve for cosine of t. And when we solve for cosine of t, we get x over 2. And when we solve for sine of t, we get y over 3. Okay. All right, that's fine. Well, let's use that. Let's use the Pythagorean identity. Cosine squared of t plus the sine squared of t is equal to 1. Well, so what are we saying here? What are we doing? Well, we're going to square both sides of each of these equations. Okay? When we square both sides of each of these equations, cosine squared of t is just x squared over 4, right? X squared over 4, or x over 2 squared, okay? And then when we square the sine of t, what we're really doing is squaring y over 3. And when we square y over 3, we get y squared over 9 is equal to 1. So what we did here, we just totally eliminated the parameter t, and we got an equation involving x's and y's. Well, what is that equation the equation of? Some of you might be thinking it's a circle. I've heard the answers circle, parabola, hyperbola, and ellipse. And this is in fact an ellipse. Okay. And the ellipse, and the thing that I never remember is which, remember when you studied ellipses, you had a major axis and a minor axis? Well, I never remember which is which, but if we look back at our previous slide, look at 2, 0 is right there, and 0, 3 is right there. So if we go back here, we go 2, 0, here the ellipse, 2, 0, ellipse looks like that. Okay. Now if we kept going around to 2 pi, from t equals 0 to t equals 2 pi, we'd get all the way back to the beginning. Okay. But anyway, that just illustrates to you that this previous slide, all these values that we found, help us to figure out that these parametric equations show the path of this moving object around the ellipse that goes through the points that we see here, 2, 0, 0, 3, and negative 2, 0. So this is the answer. Just to make sure you're well aware, this is your answer, because you were limited to an interval of 0 to pi. In other words, t is ranging from 0 to pi, and this is where you start, and this is where you end. Okay, right there. Got it? All right, that's an 11-minute video. Next video should be hopefully the last one. But what I'm going to do here is I'm going to give you one to do on your own, and I'll pick it up in the next video. The one I would like you to do on your own is x equals 2 cosine t, y equals the sine of t, and I want you to let t go from 0 to pi over 2. Okay, so graph these parametric equations, and I'll pick you up in the next video.